So for today's lecture, I'm just going to run a regular lecture. So the lecture that would have been held on Thursday. Right. Okay, so we were talking about regular expressions. Oh, there's a lot of you here who normally aren't here, right? There's like 3 times as many students as there are normally here. If you want to go, you can go. I'm not going to hold it against you. Okay, so here we go. Today's lecture. So we were talking about regular expressions, right? Now remember, a regular expression. Okay, so I have to emphasize. Okay, so first of all, if you're going to stay, I need you to stop talking because it's really annoying. All right, thank you. So regular expression. So there's something I can't emphasize enough. If you're writing a regular expression, you have to remember that the regular expression, it uses the same symbols as a bash pattern match. So it uses the star and the question mark. But the star and the question mark means something completely different in a regular expression compared to what it means in a bash pattern match, right? So if you're writing a regular expression, you have to get it in your mind, oh, I'm writing a regular expression, I'm not trying to match to some file name, right? I'm not trying to use wildcard matching for some file name. Similarly, if you're writing a wildcard match, right, you have to remember I'm writing a wildcard match to some file name. I'm not writing a regular expression, right? So the regular expressions, they have their own language. And so you have to, when you're writing one or the other, right, whether a bash pattern match or a regular expression, you have to be very clear on what it is you're writing. Okay, so the regular expression defines a pattern that can be matched, right? So if you have a string, you want to know, does that string match a pattern, right? Sometimes it's possible to write a regular expression, right? So examples of when you might do this, right? You might have a postal code. You want to validate, is this a postal code, right? Is this an integer value? Because in bash, everything's a string, right? So the only way to find out if something's actually an integer is to try to match it to some pattern that describes what an integer looks like, right? You can try to write a regular expression for floating point numbers. You can write it's possible, but extraordinarily difficult to write a regular expression that matches email addresses, right? If you Google regular expression email address, hopefully you will find the correct page where there is this gigantic regular expression that describes what a valid email address can be, right? So writing regular expressions, they let you express a pattern. It's not always easy to write the regular expression to express the correct pattern. Okay, so when you write your regular expression, it can consist of regular characters, right? A, B, C, 0 through 9, and so on, right? So none of the special symbols. If you're writing a regular expression that contains those characters are matched exactly, right? So A matches A, B matches B, and so on and so on. You are allowed to insert special characters into your regular expression called meta characters, right? So the meta characters have special meaning, right? And so here's a table of all of them, right? So at some point, you're going to have to refer to this table or a table similar to it somewhere on the internet, right? I'm not going to go through all of these right now. Instead, I'm just going to show you some regular expressions. Okay, so here are some simple regular expressions. So if your regular expression is the string hello, right, then any string that contains hello matches that regular expression. Right? So any string that contains the string hello matches that regular expression. Right? So for example, the string, let me just quickly pull up my little regular expression matching program. See. Where are we? 20, 23. Where are the scripts? Okay. So you have this little program called test regex. Right? And so test regex will let you type in a string, and it'll let you type in a regular expression, and you can test whether or not the string matches the regular expression. Right? So test regex, so I want to know, so I claim that hello. So the regular expression hello should, any string that contains the words H-E-L-L-O in that order will match that regular expression. Right? So the string hello is matched by the regular expression hello. Right? So remember, it's any string that contains hello. Oh, sorry. So this string contains hello. Right? So now I'm going to check, does this string contains hello, does that contain the string hello, the regular expression hello? And that's true. Right? So if your regular expression consists just of regular characters, then it detects whether or not the string contains any of those characters. Right? So does it contain the letter A? The answer is no, right? It's not matched. Right? Does it contain the lowercase o? Yes, it does match. Right? Okay, now you might want to exactly match the string that you're looking for. Right? So if you want to exactly match the string that you're looking for, you need what are called anchors. Let's scroll back up to the table. Okay, so the caret, shift 6 on most keyboards, right? That's called an anchor. So that matches the beginning of a line when it's used as the first character of a regular expression. So if it's the first character of the regular expression, then you say, I want the string to start with. Right? So caret HELLO says the string must start with the string, I guess to be precise, caret H means the string must start with an H. Right? The dollar sign is the anchor for the end of the line. Right? So the dollar at the end with an O in front of it says the line must end with an O. Right? And then the stuff in between says that these letters must match as well. Right? So this regular expression says, right, starts with an H, followed by ELL, ends with an O. Right? So that string so the only string that matches that regular expression is the string hello itself. Right? So you need the starting anchor and the ending anchor in this case, if you want to match a string exactly using a regular expression. All right. So the period or the decimal point. So the period or the decimal point matches any single character, right? Not including the empty characters. So there's no empty characters. So any single character. Right? So this says starts with any single character, followed by ELL, ends with an O. Ends with an O. Right? And so there are many strings that will match that regular expression. I guess let's go back to the test program and look at this one to see exactly how this works. Okay, so we've got caret and dollar sign at the end. Right? Okay, so there the string hello is matched by the regular expression, starts with an H, ends with an O, has ELL in the middle. Right? If you try this string has hello, contains hello, right? That does not match, right? It says it's not matched. Why doesn't it match? Because it doesn't start with an H, right? It starts with a T, so it doesn't match here, right? Even though it ends in hello, right? That's not enough to satisfy the regular expression. Okay, change the first H to a period, right? This says match any string that starts with anything followed by ELLO, and then ends with an O. Right? So hello matches that regular expression. Right? Change the H to something else, so jello also matches that regular expression. Right? But if you end in any character, if you end with a character that's not an O, like an X, right, it will not match the regular expression. Okay, so you can use, so the period just means any character, right? So if you want to match any two characters after the H, right, it's just H period period LO, right? So that will match any one of the strings there, right? So starts with an H, any two characters, LO. If you have the square brackets and stuff between the square brackets, that will match any single character inside the square brackets. Right? So any one of the characters, right? So this regular expression says, starts with an S, right? Ends with a T. Between the S and the T, there can be one of A, E, or I. Right? So that matches the string sat, set, and sit, and that's it. Right? You are allowed to use a range when you're defining what's called a character class. So the stuff in the square brackets is called a character class. Right? So you're allowed to use a range. So A through Z matches any of the characters lowercase a through lowercase z. Right? So this regular expression says starts with an S, ends with a T, right? Has any lowercase English letter in between, right? So SAT, SBT, SCT, and so on through SZT. Okay, so the problem with the hyphen is it's used to define a range, right? So if you want to match the hyphen and you're inside a character class, the hyphen has to be the first character of the range, right? So the hyphen as the first character means the character class is the hyphen or any of the characters A through Z, right? So that will match S hyphen T, SAT, SBT, and so on and so forth. You can use numbers in a range, right? So that will match any of the strings file 0 through file 9. If you want to match the literal period, you have to put the period inside of a character class, right? Remember, outside of a character class, the period means match any single character, right? So if you want to explicitly match the period, right, put the period inside of square brackets, right? This regular expression says starts with an A, starts with an A, followed by the period, ends with a C, right? So that matches A dot C. Okay, so any single character that's not a meta character, something called a sub-expression and something called a bracket expression, these are all what are called atoms, right? So the quantifiers, star, question mark, plus, and this notation here lets you specify how many atoms must match, right? Okay, so any single character that's not a meta character, a sub-expression or a bracket expression is called an atom, right? All right, so what does this do? Okay, so that regular expression there, so that's a meta character, but it still works in this example, right? So this says, right, so that's any character, any single character. The star means 0 or more times, right? So back up to the table, right? Match the preceding element 0 or more times. Right? So any character, 0 or more times, right? It's inside the caret and the dollar sign, right? So that matches any string, including the empty string. The plus sign means 1 or more times, right? So star, 0 or more, 1 or more, right? So caret, any character, 1 or more times. So that matches any non-empty string, right? So this is one of the ways that you can detect whether or not a string is empty in Bash. You shouldn't do it this way. There's a better way to do this, but we haven't reached that notebook yet. Question mark means 0 or 1. Right? So caret dot question mark dollar sign means either the empty string, right? So anything 0 times, right? Or anything 1 time, right? Any character 1 time, right? So that's all strings of length 1 or the empty string. Okay, so here's the character classes once again. Right? So 0 through 9 means that your string will match if it contains a digit in it. Right? So remember, it doesn't have to be a digit. The string just must contain a digit. Right? So this could be ABC 1, 2, 3, and that would match that regular expression. So 0 through 9, and then a plus after the whole thing in square brackets means any string containing at least 1 digit. Right? Right? So same thing in both cases. Right? If you put the anchors in, right? So remember, this is any string containing at least one digit, right? The anchor here says it must start with, right, one or more digits. Right? Right? So the plus, right, one or more, right, of the thing in front of it. Right? So one or more digits. So that's any unsigned integer value. Right? So any sequence of digits. Right? So it's possibly an unsigned integer value, right? It could overflow, right? So in other words, you might not be actually able to use it as a proper int. You may not be able to use it in integer arithmetic because it may not be representable on your computer. Okay, so that one there is the exact same thing as the first one, except it's got a minus sign in front. Right? Now the minus sign is not inside of square brackets, so it means literally the minus sign. Right? It's not a range in this case. So that matches any negative integer value. Again, it may overflow. Right? So the exact same thing again, except this time I've got a minus and a plus and inside square brackets and a question mark in front of it. Right? So that's a character class. Right? So it says it matches either the minus or the plus sign. Right? Question mark means 0 or 1. Right? So it can contain nothing. It can contain either just the minus sign or just the plus sign. Right? And so that's a regular expression that matches any signed or unsigned integer value. Right? It can be signed, so it can have the plus or the minus in front of it. It can be unsigned, right? So there's no sign in front of it. Right? And finally, you are allowed to use the POSIX character classes inside of a character class itself. Right? So single square bracket, this starts a character class. Square bracket, colon, digit, colon, square bracket, that's the POSIX character class for all numbers, for all, single digits, right, 0 through 9. Right? So that regular expression is identical to that regular expression there. Right? That will match any signed or unsigned integer. So if you're writing a script, your script is supposed to accept an integer value, right? And you want to test, did the user actually pass in a command line argument that's really an integer? Right? This is one way to do it. Right? You can write a regular expression, test whether or not the command line argument matches the regular expression. Right? Whether or not the value overflows or not is a much harder question to answer. Okay, so we've seen the quantify plus, question mark, and star. Right? If you want to, so that's 0 or more, 1 or more, 0 or 1. If instead you need to match some other number of occurrences, you can use the braces with 2 numbers separated by commas in between to specify the range of values. So brace 1 means match the preceding thing exactly 1 time. Right? Now you have to be careful with this thing. Right? So that 1, right, affects that A, right? It doesn't affect the XA, right? It affects the thing in front of it, right? So the thing immediately in front of it is just the character. Right? So this says starts with an X, followed by exactly 1A, and then ends. Right? So that's the map matches the string XA. Okay, so 1 comma or n comma means 1 or more, right? If it's n comma, then it's n or more, right? So if you had 5 comma, it would be 5 or more. Right? And again, that thing there affects only the A in this example, right? So it starts with an X, followed by 1 or more A's, end of the string. Right? If you want an explicit range, right? So 1 comma 3 means 1, 2, or 3. Right? And again, it affects the thing immediately in front of it, so it affects the A. Right? So XA, XAA, or XAAA. All right, and then finally, we've got this thing called a sub-expression. So if you actually wanted to make, if you actually wanted 1 to 3 XAs, then you have to group the XA. right? So you group the XA into what's called a sub-expression, and the syntax for that is to use round brackets, right? So round brackets says that there's a sub-expression ABC, right? Now the plus sign, that quantifier affects everything inside the round brackets, right? So that says one or more occurrences of ABC, right? So it'll match ABC, 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 and so on and so on and so on, right? So if you actually need to match, multiple occurrences of a string longer than one, right? You can put that string that's longer than one inside of round brackets, and then that gets treated as an atom. Okay. If you have multiple regular expressions, you can join them together using the vertical bar. Right? So the resulting regular expression matches any string that matches either of the joined expressions, right? So this is sort of like OR regular expressions. And this is tricky to use. So you need to look at the regular expression in front of the bar, and you need to look at the regular expression that's after the bar. A bar B, so the regular expression in front is A, right? The regular expression in the end is B, right? So that matches any string that contains an A or a B. Okay, so the regular expression in front starts with B, right? The regular expression at the end is CA ends with T, right? So that matches any string that starts with the B, right? So it matches any regular expression that matches that, right? Starts with the B, right? Or matches that, right? That basically ends in cat. Right? So regular expression in front starts with the B. Regular expression at the end, right? So starts with a C, right? Starts with a C followed by AT. Ends with a T. Okay, so this one is slightly confusing. So now that you've got, this one is grouped, right? So this is grouped. So when you look inside the subgroup, right, you see a vertical bar. So the regular expression in front of the vertical bar starts with the B, right? The regular expression after the vertical bar starts with a C, right? Then all of that is followed by AT ends with T, right? So that matches bat or cat, right? Match anything that starts with a B or starts with a C followed by A ends with T, right? Cat. Right, and at some point in time, you should play around with these to figure out exactly what do these match, right? It turns out those regular expressions there, those will match things that look like dates, right? So sort of look like dates, right? They'll match dates that start with the year 1900 or 2000, right? And so you can puzzle your way through these to figure out exactly what these match. All right, so what can you do with a regular expression once you've written one? So the first thing that you can do is if you scroll all the way back to the top of the notebook. Right? So in a lecture or two, I guess it's going to be after reading week now, right? You're going to learn how to write an if statement, right? And so the if statement here, right? $string equals tilde, dollar regular expression, right? That thing there tests whether or not the string stored in str matches the regular expression stored in RE. Right? So number one, you can test, does this string match a regular expression? Right? But you can also feed the regular expression to programs or commands that accept regular expressions. Right? And so grep is one of these programs. So grep is short for global regular expression print. Right? So it's one of many programs that use regular expressions as one of their inputs. Right? So what grep does is that it will search a file or files, right? So one or more files. It'll also search standard input if you want, right? And it will look for lines in the file or standard input that match a regular expression. Right? Now it turns out there's many different flavors of regular expression. The ones I've been talking about are what are called the POSIX extended regular expressions. So if you're using grep and you want to use the regular expressions that I've been talking about, to be safe, you should pass in the big minus E option, right? And that will force grep to use POSIX regular extended. Otherwise, grep uses a subset of the ones that I just talked about. Right, so the way you use grep is grep minus E. Sorry. If there's any options you need to pass to grep, just pass in the options. Right? You give it a regular expression, and then you give it the name of one or more files, right? And it will search those files for a regular expression. So if you want to search for a piece of text inside of one or more files, then grep is one of the tools that you might consider using. Turns out that if you work with a lot of text files, this tool is wildly useful. Right? It'll also read from standard input, but that's less common. Okay. So remember the directory root user bin, right? That's the directory in Linux, well, most Linux distributions, that contain the executable commands known to your computer, right? Many of the executable commands known to your computer. Right? So if I want to know, right, is there a program whose name contains the string zip, right? I can call grep like this, right? So I can list the contents of the directory, right? I can pipe the output of ls to the program grep, right? So grep takes from standard input the output of ls, right? And it tries to match all of the lines produced by ls to the regular expression zip, right? So remember what the regular expression zip means? It means does a string contain the characters Z, I, and P in that order? Okay, so files that contain zip, right? It turns out there are several of them. Can I scroll this? There, up to there. Right, so let's very quickly look at the command line. So ls root user bin. Right, so what does it output? Well, it outputs this long list of files. Right. Now, it turns out that when you pass the output of ls to another program, everything that ls prints, all the files that ls prints, each one gets printed on a separate line. Right. So does the output of ls contain the string zip, right? And if it does, print out the lines that contain the word zip, right? So it prints out all of those files there. Okay, what about the files that start with zip? Right, so these are all the files that contain the word zip. Suppose I'm looking for a program whose name starts with zip, right? And so you put in the anchor, right? So starts with a Z, followed by IP, right? Could end with anything, right? You're not specifying what it ends with, right? So everything that starts with zip gets printed out like that. Right? And then finally, anything that ends with a zip, well, you just use the end anchor instead. Right? So, whoops, sorry, dollar at the end. Right? So, regular expression says ends with a P, right? There's a ZI in front of it, but the ZIP could be anywhere, but there could be anything in front of the Z, right? So you're not specifying what's in front of the Z, right? And so you get all of those right there. Right? And of course, if you want to match only zip, right? Caret zip $, right? And now you only get the string zip. Right? Now, of course, you wouldn't normally do this, right, with ls. With ls, you would just write user bin zip, right, and that works. Right? So this is just an example of showing you that grep will read from standard input as well. Okay. Oops. So if you pass in the -n option to grep, it prints the line numbers of all the matching lines. Right? So I've got this little program here. It's a little Java program, right? And so whenever you're working in a programming language, often, well, there are standard constructs inside the program, right? So inside of a Java file, you might find a package declaration, you might find a class name, you might find a class or interface name, you might find a loop, right? So I might be looking for all the loops inside of this file, right? And so this little grep command will do that for you, right? So look for any line that contains the keyword for, F-O-R, right, in this file here. Hopefully this works. It does, right? So on line 82, right, line 82 has that string on that line. Well, line 82 is the string for string word blah, 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 right? Now, this doesn't just find all the loops, all the for loops, right? It can find any string that contains the word for, right? So this also finds the comment that contains the word for, right? So if you want to search for some sort of construct inside one of your program files, right, regular expression is probably not the, so regular expression is one way to do it, but it will probably return back more matching lines than you are hoping to find, right? So in other words, I can't just look for the for loops, right? I'm looking for anything that contains the string for, any line that contains the string for, right? Now you might say, well, look, in Java, a for loop always is followed by a round bracket, right? So maybe I can search for that instead, right? So maybe I can search for, followed by 0 or more spaces, followed by the opening round bracket, right? And so can you write the regular expression for that? The answer is yes, you could write a regular expression for that. Right, so I want to look for the word for, and now I want 0 or more spaces. Now the problem is in Java, a space isn't just a space. It can be the tab character. It could also be the new line character. Right? So it's not sufficient to just look for spaces. You have to look for all white space. Right? And the easiest way to say all white space is with the POSIX character class blank. Right? Remember, Java doesn't care about lines. Java doesn't care about white space at all, right? You can put as many tabs or new lines into your code as you want, right? So, keyword for, followed by, come on. Oh, sorry, I should have brought a mouse. Come on. So the keyword for, right? Star means 0 or more, right? It affects the thing in front of it. Right, so it affects that, right? So for followed by 0 or more blank spaces, followed by the opening round bracket. Notice here I can't just write the round bracket, right? Why can't I write the round bracket? Because the round bracket's a meta character, right? It indicates a sub-expression. So if you want to match the round bracket, it has to be inside of square brackets, right? And if you run that, now you only get the lines that appear to contain a for loop. Okay, if you have an HTML file, you can look for all of the anchor tags. If you don't know what HTML is, or if you've never written HTML, don't worry about it, right? So anything that you can click on in HTML is an anchor, right? Usually, but not always, they're marked with something that starts with the opening, what's it called? The opening, so the less than sign followed by an A. Right? And so that will find, or that will attempt to find all of your anchor tags inside of an HTML document. Right? And finally, if you like to play word puzzles, then you can use grep to help you solve your word puzzles. Right? So for example, if you're trying to fill in a crossword, you know the second and third characters are AK, second, third, fourth, fifth. The fifth character is an S, and you want to find all the words that match that pattern. Right? You can use that, right? So it starts with something, followed by AK, followed by something, followed by S, right? If your particular computer has this file stored on it, that's a list of, that's a not great word of English lists. That's a not great list of English words, right? So you can search that file for anything that matches that pattern, right? And so there are all the words in that particular file that contain that pattern of characters. All right. So when should you use a regular expression? So you should use a regular expression when you're trying to match some pattern, right? So you're searching for a file or searching for a large body of text, and you want to find the occurrences of those patterns in that text, right? Now the problem is when you write a regular expression, it's easy to write a regular expression that matches the thing you're looking for, right? It's very hard to write a regular expression that only is the thing that you're looking for, right? So here's a quote by some guy on the internet. He happens to write this blog called Coding Horror. So he says regular expressions are like a particularly spicy hot sauce to be used in moderation and with restraint only when appropriate, right? And so normally what happens when you show programmers regular expressions, they start to use them for everything, even when they're not appropriate, right? So they're powerful, but they're very hard to read and write, right? If you want to know, or if you ever have to write a regular expression for something that's more important than CISC 220, right, you may want to consider looking at other resources other than the stuff I just told you. Right? There are entire textbooks or manuals written about regular expressions. Right? I think the first link in particular, yes, the premier website about regular expressions. Somewhere in here, there's a regular expression. It shows you what the regular expression that matches an email address is. I don't want to root around for it right now. When you find it, you'll see that it's this enormous regular expression. All right, so I think that's all I want to talk about for this week. So next week, we're going to look at arrays, if statements, and loops, and I guess functions. So that'll be week after reading week, and that will basically close off the first part of the course, right? After that, we're going to transition into the C programming language. So that'll be the second week after reading week.